Hello. Hello, and welcome to this review of PostgreSQL functions and operators. In this video, we will continue with string functions and operators. So apart from other functions and operators, this is probably going to be most useful and most common functions and operators. These will be So when you will be doing actual SQL queries, string functions and operators will be very helpful to do various manipulations, probably generation in your queries. So without further ado, let's get started. We will see some examples of functions and operators as well, but mostly it will be read through. So this section describes functions and operators for examining and manipulating string values. Strings in this context include values of the types, character varying, and text. Except where noted, these functions and operators are declared to accept and return type text. They will interchangeably accept character varying arguments. Values of type character will be converted to text before the function or operator is applied, resulting in stripping any chaining spaces in the character value. SQL defines some string functions that use keywords rather than commas to separate arguments. Details are in the table 9.9, which we'll see. PostgreSQL also provides versions of these functions that use the regular function invocation syntax, which will be in table 9.10. The string concatenation operators will accept non-string input as so long as at least one input is of string type, as shown in table 9.9. For other cases, inserting an explicit cursor to text can be used to have non-string input accepted. So the first is concatenation operator, that is 2 bytes, and it will apply on text and will give us text. So the simple example is select, let me copy this, and we see it concatenates those. So as it said, you can have one type is text. Okay. The other type can be coerced to text. So you can concatenate numeric types as well. Suppose we want to have floating point numbers, we can have 5.7 and so on. Then we have text with anonymous array. Any non-array converts the non-string input to text and then concatenates the two strings. The non-string input cannot be of an array type because that would create ambiguity with the array concatenation operators. If you want to concatenate an array's text equivalent, pass it to text explicitly. So an example is value colon space 42, which will give you value 42. Then we have btrim, which takes one argument string text and another optional argument of characters of type text. Removes the longest string containing only characters in characters space by default from the start and end of the string. So example would be select btrim, and then in that we give something with space and probably backslash t and more space. Okay. Sorry. This was at one place. And you see white space is string, backslash t is not string. So what you can do is you can give another here. Okay, it did not print backslash t. All right. That is change. So seems to be something problematic. So it returns start and end of the string. So it should be a space by default from the start and end of the string. Okay, let's do this. And then what we do is we put here, let's make this. So the text should be both at the start and the end of the string. So we have this. We put that first one, and then it is done. So both, it should be at both the start and the end, otherwise it won't strum. So for example, if you see these examples here, the space at the beginning is not trimmed, and there is space after this also. Let's see carefully that in this example as well, and in this one as well. Okay. All right. So it stems from both ends, not only one end. Okay. Then we have text is not form normalized. Checks whether the string is in the specified Unicode normalization form. The optional form keyword specify the form NFC by default, NFD, NFKC, and NFKD. This expression can only be used when the server encoding is UTF-8. Note that checking for normalization using this expression is often faster than normalizing possibly already normalized string. Then this is, I don't know these normalization schemes, so I'll have to probably read on this, and then I'll get back to you. Then we have bit underscore length, return number of bits in the string, each times the octet length. So, for example, we select that is 32. Then we have char length and character length, which returns number of characters. Then lower will convert text into lowercase. For example, select. Then we have lpad, string text length, integer, and then finally a fill text. Argument is taken by lpad. Extend the string to length by appending the characters fill a space by default. If the string is already longer than length, then it is truncated. So you have to be careful that if the string is already longer than length, then it will be truncated. So, for example, we take this, select. The condition example would be hello world. Okay, and it is truncated. Then we have ltrim removes the, similar to btrim, removes the longest string containing only characters and characters is by default from the start of the string. So this is like btrim but works only on the left side. Then we have normalize, which take text and form. Once again, I don't know the normalization forms here. Converts the string to the specified Unicode normalization form. The optional form keyword specify the form NFC, NFD, NFKC, and NFKD. This function can only be used when the server encoding is UTF-8. Then we have octet length. Returns the number of bytes in the string, so octet length of Joe's is 5. Note that this is not E, this is E with accent, so it is a Unicode character and occupies 2 bytes. Select. Then we have another octet length which operates on character, returns number of bytes in the string. Since this version of the function accepts type character directly, it will not skip the spacing. So, for example, in this one, octet length of ABC space, and it is connected to character 4, gives us 4. Overlay, string text, placing new substring text from start integer for count integer. Replaces the substring of string that starts at the started character and extends for count characters with new substring. If count is omitted, it defaults to the length of new substring. So overlay, we have Thomas and it, TXX, XXAS, and it places HOM from 2 to 4. So this is 1, this is 2, 3, 4. for 4. Sorry, for 4. So from 2 to 4, 4. So 1, 2, 3, 4, all x will be removed and norm will be placed over there. Then we have position substring text in string text. Returns first starting index of the specified substring within string or 0 if it is not then. The position of home in commas is 3. So PHNO. RPAD will be analogous to LPAD, but it operates at the right side of the string. RTrim is like LTrim and BTrim, but remove characters from the right side. Substring. It takes string text from start integer for count integer. Extracts the substring of string starting at the started character if that is specified and stopping after count characters if that is specified. Provide at least one of start and count. So substring Thomas from 2 for 3. So we start at H and take 3 characters. Thomas from 3 will take Thomas. And Thomas for 2 will be starting from G1 and that will be TH. Then we have substring, string text from pattern text. Extract the first substring matching politics regular expression. We'll see regular expression soon enough. So substring Thomas from triple dot dollar. So dollar means end of string and 3 dots will match 3 characters. So it will be MIS. Then we have substring string similar pattern state. And then string from pattern for state. Extracts the first substring matching SQL regular expression. The first form has been specified since SQL 2003. The second form was only in SQL 99 and should be considered obsolete. So Thomas similar to percentage hash O underscore A hash underscore state. So this we will have to study regular expressions, otherwise we cannot explain this. But please wait till the regular expressions are covered and then we will come back to this subsequently. There are lots of regular expression based functions which we will study. So basically what it does is, I'll tell you, so it will match percentage, this is escape character, so double quotes, O underscore A hash. So it will match anything which in between the string or anywhere in the string which has O some character and then A. So it will match some of it O and A. Then we have trim similar to B trim. It can trim leading, trailing, both and characters. So you can give both and it will act like B trim. If you say leading, then it will act like L trim. And if you give the trailing, then it will act like R trim. Similarly, we have trim which operates on string text and characters text. This is a non-standard syntax for trim. So this is how we can do it. Unicode underscore assigned returns true if all characters in the string are assigned Unicode code points, false otherwise. This function can only be used when the server encoding is UTF-8. Upper will convert string to uppercase. Like lower, it is the converse of lower. Additional string manipulation functions and operators are available and are listed in table 9.10, which we'll see. Some of these are used internally to implement the SQL standard string function listed in table 9.9. There are also pattern matching operators which are described in section 9.7 and operators for full text set which are described in chapter 12. So first is caret at the rate. So it operates from two text binary operator. It turns to if the first string starts with the second string equivalent to starts with function. The alphabet starts with alph, so it will be true. Let me show you. For example, collect, and it is true. When we have ASCII text and output is integer, returns the numeric code of the first character of the argument. In UTF-8 encoding, returns the Unicode code point of the character. In other multiplier encodings, the argument must be an ASCII character. Then we have CHR integer, which gives you text. Returns the character with the given code. In UTF-8 encoding, the argument is treated as a Unicode code point. In other multi-byte encodings, the argument must designate an ASCII character. CHR0 is disallowed because data types can store that character. So pretty simple, gives you ASCII code, ASCII gives you ASCII code, and CHR gives you ASCII character. Then we have concat, which concatenates various values. Concatenates the text representations of all arguments, null arguments I know. So this can take multiple arguments and concatenate them in one go. Like concat underscore ws concatenates all but first argument with separators. So first argument is a separator. The first argument is a separate string and should not be null. Other null arguments are ignored. So concat with separator. Okay. So we do select and with separator we concatenate. We get A, B, C, D, E, Then we have format. Format arguments according to the format string, see section 9.4.1. We'll go to this. This function is similar to the C function, sprintf. So we'll see this in lots of detail in its own section. Then we have init cap, converts the first letter of each word to uppercase and rest to lowercase. Words are sequence of alphanumeric characters separated by non-alphanumeric characters. So, for example, select case fold, performs case folding of the input string according to the collation. Case folding is similar to case converting, but the purpose of case folding is to facilitate case insensitive matching of strings. Whereas the purpose of case conversion is to convert to a particular case form. Case function can only be used when the server encoding is UTF-8. Ordinarily, case folding simply converts to lowercase, but there may be exception depending on the collation. For instance, some characters have more than two lowercase variants that fold to uppercase. Case folding may change the length of the string. For example, in PG underscore Unicode underscore fast collation, beta folds to SS. Case folds can be used for Unicode default caseless matching. It does not always preserve the normalized form of the input string. The libc provided does not support case folding, so case fold is identical to lower. Then we have left, which takes two arguments, string and n, returns first n characters in the string, or when n is negative, returns all but last modern characters. So see this, and we will select. And if we give it negative, we'll take those many characters, skip those many characters from the right hand side. And it's negative, returns all but last. Length is text, and returns the number of characters in the string. So very simple. MD5 computes the MD5 sum of the argument, which returns in hexadecimal. This can be quite useful. You can then we have parse underscore ident, qualified identifier, and stick mode is a boolean, default is true. Splits qualified identifier into an array of identifiers, removing any quoting of individual identifiers. By default, extra characters after the last identifier are considered an error. But if second parameter is false, then such extra characters are ignored. This behavior is useful for passing names for objects like functions. Note that this function does not contain overlength identifiers. If you want truncation, you can cast the results to name. Then we have PD underscore client underscore encoding, which returns current client encoding name. Then we have port identifier, returns the given string suitably coded to be used as an identifier and a SQL statement string. Ports are added only if necessary. That is, if the string contains non-identifier characters or only case folded. Embedded codes are properly doubled. We also example 41.41. Support identifier, if you apply on foo bar, it will give you foo space bar that. Then we have port literal, which takes the text, reserves the given string suitably coded to be used as a form as a string literal in a SQL statement. So I'll show you an example of this. So select, and suppose we have double quotes here. Double quote that as well. Okay. So port literal returns a given string suitably coded to be used as string literal in a SQL statement string. Embedded single quotes and backslashes are properly doubled. Note that port literal returns null or null input if the argument might be null. Port nullable is often more suitable. So port literal, for example, it takes port backslash single quote value, it doubles the port, so it becomes two single character. Then we have port literal, any element converts the given value to text and then quotes it as a literal. So we have port literal applied on a number, we have 42.5. Then we have port nullable, which can optionally take null, and if input is null, output will be null as well. Port nullable, any element works analogously to port literal. Then we have regex p underscore count. So examples of regex functions will be given after we have studied the regex. So let's go through the description of regex functions. It takes string, pattern, start, flags. So it returns the number of times the project's regular expression pattern matches in this string. Regex in str takes a string, pattern, start, and end option, flags, sub expression. Returns the position within string where the nth match of the project's regular expression pattern occurs, or 0 if there is no such matches. We will come back and we will see examples of regex once we have finished the regex section. Regex p underscore like takes a string, pattern, and flags. Checks whether a match of the project's regular expression patterns occur within string. Regex p underscore match takes a string, pattern, and flags. Returns substrings within the first match of the project's regular expression pattern to string. Then we have regex p matches, which returns an array. Returns substring within the first match of the project's regular expression pattern to the string, or substring within all such matches if G flag is used. Then we have regex p replace, takes a string, pattern, and replacement text, optionally flag. Replaces the substring that is the first match to the project's regular expression pattern, or all such matches if the G flag is used. Regex p underscore replace, it takes a string, pattern, replacement, start, and integer flags. Returns a substring that is the nth match to the project regular expression pattern, or all such matches if n is 0. With the search beginning at the started character of string, if n is omitted, it defaults to 1. Regex p splits to array, takes a string and a pattern and flags. Splits strings using project's regular expression as the delimiter, producing an array of results. Regex p splits to table, splits the string to a table. Regex p underscore sub str, it returns the substring within string that matches the nth occurrence of the project's regular expression pattern, or null if there is no such match. Then we have repeat string the specified number of times. So if you have a pg as string and 4 as the number of repetitions, it will repeat 4 times. Then we have replace, it replaces all occurrences of string, that is this, and string of substring from with substring to. So suppose we have A, B, C, D, E, F, A, B, C, D, E, F, and we want to replace C, D with XS. Excuse me. Then now occurrences of C, D will be replaced by XS. Then we have reverse, which reverses the order of characters in the string. We have right, returns last 10 characters of the string. When n is negative, return all but first modern characters. We have split part, which takes a string, delimiter, and n. Split string at occurrences of delimiter and returns return of field, or when n is negative, returns the modern field from last. So you can look at the examples and see how they work. Then we have start field, which takes a string and a prefix and returns to it the string start with prefix. Let's see how many more are there. Okay, we can finish this. So that is string with. Then we have string to array takes a string and delimiter and null string optionally. It splits the string at occurrences of delimiter and forms the resulting fields into a text array. If delimiter is null, each character in the string will become a separate element in the array. If delimiter is an empty string, then the string is treated as a single field. If null string is supplied and it's not null, fields matching the strings are replaced by null. So we have string to table. So it takes string, delimiter, and optional null and stores in text. Similar to string to array, but it will convert the output to a table. str post, so in the string, it will find the position of the substring. Returns first starting index of the specified substring within string, or 0 if it is not there. So it is similar to position, substring, and string, but in this case, the order is different. Substr, string, and start integer and count integer. Extract the substring of string starting at start of character and extending for count characters if that is specified. So at alphabet, if we give position 3, then from P it will extract the string, and if you give a count also, then it will extract those many characters. Then we have 2SP, which takes string and string optional encoding, the name of the encoding, or the code for the encoding. Convert string to ASCII from another encoding, which may be identified by name or number. If encoding is omitted, the database encoding is assumed, which in practice is the only useful case. The conversion consists primarily of dropping accents. Conversion is only supported from Latin 1, Latin 2, Latin 9, and bin 1 to 0 encodings. To bin takes an integer and begin and converts it to a binary string. To hex will take an integer and begin to convert it to hexadecimal string. 2-oct will convert to octal. Then we have transit strings from and to replaces each character in string that matches the character in the from set with corresponding character in the to set. If from is larger than 2, occurrences of the extra characters in from are deleted. So we have 1, 2, 3, 4, 5, and 1, 4, 3 is here, and those are to be replaced by a x. You see, it takes 1 from here, and for 1 it is a. So 1 is replaced with a, then we have 2, then it will look at 3. So now it will look at 4 epsilon. Okay. So for 4 it will place x, and for 3 it will not place anything. So 3 will be silently removed. Then we have UniStr from text to text. Evaluate escape Unicode characters in the argument. Unicode characters can be specified as XX, XX, or 6 hexadecimal digits, or 4 or 8. We specify backslash like 2 backslashes. All other characters are taken equally. If the server encoding is not UTF-8, the Unicode code point identified by one of these state sequences is converted to an actual server encoding. An error is reported if that is not possible. This function provides a non-standard alternative to often with Unicode states. So the concact with the separator and format functions are variadic. So it is possible to pass the values to be concatenated or formatted as an array marked with a variadic keyword. The array's elements are treated as if they were separate ordinary arguments to the function. If the valid array argument is null, concat and concat with separator return null. That format keeps a null as a zero element array. So next is format, which we will cover in the next video. So we will stop here, and tomorrow we will start with format, and we will go as far as possible. Okay. So I'll stop this video here, and I hope that you are finding this read through useful and informative. So thanks a lot for watching the video, and I'll see you in the next one tomorrow around at the same time with more on format and functions on binary strings and operators. So once again, thanks a lot for watching the video. Keep learning and enjoy.